All right, guys, what we're starting today is Chapter 2, Polynomials and Rational Functions. So what we're going to be looking at first is quadratic functions, quadratic equations. Now, our quadratic equations are our equations where the degree is going to be 2. So our x squared is going to be the variable with the biggest exponent. Quadratics, the graphs of them. So in this section, you'll study graphs of polynomial functions. We're not going to do a whole lot with them, but we will look at them, identify them, and kind of be able to understand certain parts of the graph. And we've talked about this before, ax plus b, y equals mx plus b is a linear function. It's the equation of a line. F of x equals c. C is just a number, so we could say f of x equals 7 is a constant function. So graphically, it's just going to be a flat line. And our squaring function, these are our quadratics, our U-shaped graphs. And these functions are all polynomial functions. Now, in general, the definition of a polynomial function is defined by this here, and that's any polynomial function of nth degree. A is just a number that could be positive, it could be negative, they could be the same number, but each of these a to the n, a sub n, a sub 2, a sub 1, a sub 0 is just a number. And we have x to a given power that is reducing to 1 and then 0. Now, quadratic functions are our second degree, so x squared. For instance, all of these are considered quadratic functions. X squared plus 6x plus 2, 2 times x plus 1 squared minus 3, and these here. Now, this first one is what we call standard form. It's in standard form, our ax squared plus bx plus c. The second one here is in vertex form, which is our a times x minus h squared plus k. And the last one is in x-intercept form. And these different forms have different pieces of information contained within them. But the main one and the way that we will present most of these are in standard form, our ax squared plus bx plus c, where a, b, and c are the numbers in front of our x squared, x, and our constant term. The graph of a quadratic function is a special type of U shape called a parabola. Parabolas occur in many real-life applications, and especially those involving reflective properties such as satellite dishes and flashlights. So, axis of symmetry. Axis of symmetry is the line that cuts the parabola in half. And that axis of symmetry is always going to go through the vertex. Now, the vertex in vertex form is h comma k. And the axis of symmetry for this here would be x equals h. Always goes through the center and reflects it on either side. Now, the leading coefficient is positive, the graph will open up. If the leading coefficient is negative, the graph will open down. The simplest form of this is ax squared. So the graph is a parabola, as we said, opens up if a is greater than 0, less than 0, it opens down. Now, if it opens up, the vertex is going to give us the minimum value. That y value is the minimum value of the graph, because that's the lowest point. If it's opening down, that vertex is going to be the maximum, the biggest point, because that is the biggest spot that we have. When sketching the graph of f of x equals ax squared, it's helpful to use the graph x squared as a reference. And all that means is, if we wanted to graph 1/3 x squared, we could start with our x squared and go from there. Well, that's the other one. So compared with y equals x squared, our original function, the one that's grayed out, the output f of x equals 1/3 x squared shrinks by a factor of 1/3. So we can start with the general one to get to this one here. Or 2x squared is stretching the graph by a factor of 2. So it's a way to get to our functions. Note that the coefficients a determines how wide the parabola f of x will open. When a is small, the parabola opens wider. When a is larger, then when it opens wider. So really they're saying that if a is between 0 and 1, it's going to be wider. It's a vertical shrink. If gray is greater than 1, it's going to be narrower, or it's a vertical stretch. So when a is greater than 1, it's going to open, it's going to be skinnier. When a is between 0 and 1, it's going to be wider. It's a vertical shrink. We know that the graph f of x plus or minus c, this here. So there's different ways that we can move it, because inside is going to move it left or right. Outside is going to move it up or down. Reflections across the x and y axis. All these are different types of transformations. And we have gone over these in Algebra 2 and how they affect the graph itself. So not focusing too much on those there. Standard form of a quadratic equation. They call it standard form. I call it vertex form. It is the same thing. It's our a times x minus h squared plus k. A is our vertical stretch or shrink. H and k are the values of the vertex. So the standard quadratic function, a times x minus h squared plus k, in standard form, the point h comma k is the vertex. When a is greater than 0, it opens up. When a is less than 0, it opens down. And our axis of symmetry is given to us by x equals h. Vertex is h comma k. Axis of symmetry, x equals h. And if we wanted to find the x-intercepts, all we got to do is replace f of x or y with 0. So the parabola, graph of a parabola, is helpful to begin with by writing the quadratic function in standard form using the process of completing the square. In this example, you will add and subtract the squares of half of the coefficients of x within the parentheses instead of adding the value to each side of the equation. So what we want to do with this first one here is we want to rewrite this in what they call standard form and vertex form. Now to do that, we need to complete the square. What we're wanting to do is rewrite this in this form, this a times x minus h squared plus k. So the first thing we need to do is we need to get our terms together. So we have 2x squared plus 8x plus 7. We're going to group these first two terms together, our 2x squared plus 8x, because we need to be able to rewrite this as a set of parentheses squared. And we need the number in front of x squared to be 1. So since there's a 2 in front of the x squared, we're going to factor the 2 out of both of these terms. And when we factor the 2 out of 2x squared, we get x squared. When we factor the 2 out of 8x, we have 4x plus minus. Now we leave two spaces because, again, we need to complete the square. We need to find out what needs to be added to x squared plus 4x so that I could rewrite it as a single set of parentheses being squared is the goal. Questions on this so far? Now for us here, factoring out this 2 is not always necessary. It's only necessary if there is a number in front of the x squared. If the number in front of x squared is 1, we don't have to factor that out. But since here the number is 2, we need to factor that 2 out. Now the next part is to find the number, our missing term, to make this a perfect square trinomial, to get it in standard form. And to do that, we need to find this c, this b over 2 squared. Now for us, our b term is going to be the number in front of x and its sign. Since it's positive 4, we're going to plug positive 4 in for b. First thing we're going to do is divide it by 2. 4 divided by 2 is 2. 2 squared is 4. Now, when we did this in Algebra 2, we normally added it to both sides, but here we're not going to add it to both sides. We're going to add and subtract it inside the parentheses. Because if I add 4 to it and subtract 4 from it, well, our 4 minus 4 is 0. So we actually haven't added anything to the equation since we added it and subtracted it. Questions on this so far? Now this here, the x squared plus 4x plus 4 is our perfect square trinomial and will factor. We'll have our x, and the number and sign inside the parentheses is going to be the number and sign inside these parentheses here before we square it. Since it's positive 2, the x squared plus 4x plus 4 will factor to x plus 2 squared. And yes, we are going to have to deal with this negative 4 here. Now this negative 4 is going to come out of the parentheses. Now the reason we can't just minus it on the end, we can't just add it to the end, is not just negative 4. It's also being multiplied by this 2, because every term in there is being multiplied by the 2. So we aren't really just dealing with negative 4. What we're really looking at is 2 times this negative 4, because this 2 value is affecting the negative 4 also. So really what we have, or had to add in, is we had to add in 8 and negative 8. Because we really added 8 to the function because of that factor of 2, which means we also had to subtract 8. And 7 minus 8 is negative 1. Telling us that our function in standard form is 2 times x plus 2 squared minus 1. Now there is a way to make sure that this is the correct function. Now they told us the function to begin with was 2x squared plus 8x plus 7. So I can come over here in the graphing calculator and do 2x squared plus 8x plus 7 and tell it to graph it. We get this here. Y equals, well, we found in vertex form plus 2 squared minus 1. 2 times x plus 2 squared minus 1. Okay, let's tell it to graph it. Well, we see that those two graphs overlap. They cover each other up. We can look at the table and make sure that the y values for the first, y1, and the y values in y2 are the same. Because if they do have the same values for the same x's, it means they are the same function. So this here is a way to check and make sure that this equation here we found in standard form, or vertex form, is the equation that we wanted. Now it does give us some helpful information. Like it will tell us the vertex. The vertex is h comma k. Now the k lines up nicely, negative 1. The h is inside. Since it's positive inside, it's going to come out negative. Our axis of symmetry, x is equal to h. So in this case here, x is equal to negative 2. Now we could also find the x-intercepts. Now finding the x-intercepts is going to require us to solve this. Now since we do have it in standard form, this vertex form, x-intercepts are just where it's going to cross the x-axis, where the value of y is 0. Now for us here, it's going to involve us solving this equation. And since we do have a set of parentheses being squared, we just need to get them by themselves first. So the first thing I'm going to do is add 1 to both sides, telling us 2 times x plus 2 squared is equal to 1. At this point here, we can divide both sides by 2, telling us that x plus 2 squared is equal to 1/2. Next thing we need to do is get rid of our square. And we can do that by taking the square root of both sides, because the square root and square here will cancel, leaving us with x plus 2 is equal to plus or minus. Now our square root of 1/2, we can do this in the calculator, but we do have to take the square root of the top over the square root of the bottom, telling us that the square root of 1/2 is the square root of 2 over 2. And lastly, we're going to subtract 2 from both sides, telling us that our solutions for this here is that x is equal to negative 2 plus or minus the square root of 2 over 2. Which means our x-intercepts are negative 2 plus square root of 2 over 2 comma 0, and negative 2 minus the square root of 2 over 2 comma 0. And that's it for that there. We'll pick this up tomorrow.